Morning students, I hope all of you must be revising your chapter and you all are enthusiastic. Please do the labor as unit test is approaching to us. In today's video I am going to revise your chapter and the topic that is what the parallax and the way in which we can calculate the diameter and the distance of celestial or heavenly bodies. So here it is. Good morning students. Today I am going to continue with the last lecture in which I had explained you about how you can calculate the distance of a celestial body from the earth by observing it, right? Today I am going to tell you about the calculation of diameter of a celestial body from the earth, right? So let us calculate the diameter of moon. Diameter of moon. For the diameter of moon, basically we choose a point A from the earth, and here we choose the position of moon, and we observe moon from this point like that with the help of a telescope, right? And this is what the diameter. This is linear diameter of moon, right? And here angle theta will be there. This angle theta is angular diameter, right? This is what angular diameter. Sometimes only it can be called as angle. We observe these these two distances with the help of telescope, right? So again we have to follow in the same way as I have already explained you, that we know that theta equals to arc upon radius, right? So here in our case arc is happen to be this linear diameter, so d upon radius is nothing but this distance, let it be s. Okay, so we want to calculate linear diameter, so theta into s equals to what? The linear diameter. This is nothing but linear diameter of the moon. So this is the basic fundamental formula, right? Now if values are given, if values will be given for theta and for s, right, then how to calculate and how to put the values, let us see that, right? Let this angle, let theta equals to 1920 second. Double dash means second, SECECO and D, right? This is what the practical unit of small angle, second. And distance s has also been given as 1.496 into 10 to the power 11 meter. Now if these sort of informations are being given over here, so we can easily put the values in place of theta 1920 and in place of s 1.496 into 10 to the power 11 meter. But one problem is here. The problem is that the second 1920 second, that is what given over here, is not the SI unit for the angle. SI unit for angle is radian, right? SI unit for angle is radian, right? RAD, radian. Okay, so we need to calculate that 1920 second has how many radians, right? So we should apply this. Now we know that. What do we know that? We know that 1 second equals to 4.85 into 10 to the power minus 6 meter. Sorry, radian. 4.85 into 10 to the power minus 6 radian. Okay. So we will multiply this with our given value. That is what? Theta equals to 1920 into 4.85 into 10 to the power minus 6. Okay. So theta comes out as in radian, that is what the SI unit. Okay. Proceeding with the same. Now we have SI unit over here and SI unit over here. So we will put this value and this value in this formula. So let us put it. So 1920 into 4.85 into 10 to the power minus 6 into 1.496 into 10 to the power 11 equals to linear diameter of the moon, right? This is what we come out with the answer, which is equivalent to linear diameter of the moon is equivalent to 1.39 into 10 to the power 9 meter. So this is our answer. Okay, so this is the way in which we should calculate the linear diameter of any celestial body. I hope all of you have understood this. Okay, and in the previous lecture already I have explained you that how to measure the distance. Both the methods here and in the previous lecture, both are related with parallax method, right? I believe all of you must have understood this one. This was the part actually left in the last lecture, right? Now let us proceed for the next topic. Here next topic I am going to take as mass and weight. Mass and weight. Now you all know about mass. You all know about mass. Mass is the total matter contained within the body and it remains almost constant everywhere. Okay, so that is mass, and its value do not changes whenever you go from one planet to another planet or any other celestial body. So it always remains constant, right? But one more thing I would like to add here and mention here, that Albert Einstein, the great scientist, had given a theory called as a relativity theory. According to that theory, the mass of object changes. According to that theory, the mass of object also changes. Now it is very interesting to know that at one end I am saying that mass remains constant, and at another end I am saying that it also may change. But this is true. Mass can also change, although the change is very very less, but it can change when the speed changes of a body, right? So how it happens? Let me tell you the formula for that one. According to theory of relativity, mass nu equals to mass old upon 1 minus v square upon c square, right? This is new mass of which the value is needed to be calculated. This is the old mass, original mass, and this is what in denominator 1 minus the velocity acquired by u, and this c is the velocity of light. This is the velocity acquired by u, and this is the velocity of light. Now if v square equals to c square, now here note the point, it is if your velocity, that is v, becomes equal to velocity of light, then what happened to this formula? Then this formula will change like that: mass nu equals to mass old upon 1 minus c square upon c square, that is mass old upon 1 minus 1, right? That is m by 0, that is nothing but infinity, mass nu. Hence by this calculation we come to know that when our speed, our velocity will become equal to velocity of light, then the new mass, that means the existing mass, whatever it may be, becomes infinity. But this happens only when v equals to c, that means your velocity is equals to velocity of light. So mass changes according to this formula, and this is nothing but Albert Einstein famous relativity formula. Albert Einstein relativity formula, that is also called as what? Theory of relativity. So as if now we mention that mass remains constant, mass remains constant, right? But it changes according to the velocity of light, although the velocity will never become equal to velocity of light. But in science we cannot say what happens at what time. Right now it is impossible to have the velocity of light because mass becomes infinity, and if mass becomes infinity, that means what will happen to universe? It's a big question. That means an individual velocity, if it becomes equals to velocity of light, then the individual mass becomes infinity. That means more than the mass of sun, more than the mass of galaxy, more than the mass of universe, which is impossible. So whatever the science and physics available right now, that doesn't suggest that it will be equal to velocity of light. That means an individual velocity cannot become equal to velocity of light, right? So as if now we say mass remains constant. Now what about weight? Weight depends on gravity of an object, gravity of any planet, right? Weight depends on gravity of any planet. So weight do changes, right? Weight do changes. Weight, weight, weight equals to mass into gravitation. I believe you must be knowing this formula, mass into gravitation, because in old classes already you have learned it. That means in the previous classes, in the lower classes. So here we are seeing that weight depends on gravity. So weight changes according to the change in gravity, right? And we know that the value of g, the value of g, the value of g becomes 0 at the center of the earth, right? The value of g at the center of earth becomes equals to 0. Therefore weight at the center of earth becomes 0, right? Interesting fact, this one. But mass remains constant. There is not any change at the center of the earth or at the crust of the earth for the mass. But since g has become 0, so weight has also become 0. Now on the surface of earth, on the surface of earth, the value of g varies. As we move from equator to pole, then also there is change in gravity, right? We know a formula, that is g equals to capital G mass of earth upon radius of square. According to this, g is inversely proportional to radius of the earth, and we know the shape of earth is like that. If this is radius at equator and this is radius at pole, so here we are noticing that radius of pole is less than radius at equator, right? And here g is inversely proportional to radius. That means if radius at pole is less, that means gravity is more. Gravity at pole is more than gravity at equator, right? So at pole weight becomes more. So weight at pole is greater than weight at equator, right? So this is another fact that we should know. And one more thing, ki what will happen if I should say, is there any methodology by which we can decrease the gravity of any planet? Can we decrease or not? Can you suggest any idea about it? Any planet, can you decrease the gravity of that planet? No, we can't decrease or increase the gravity, right? So this is what happens. This is what the fact about weight and mass, right? One more thing I would like to tell you is that weight is not the essential property, right? But mass is the essential property of any object. Without mass, the existence of that object is not possible. But without weight, an object can exist, right? Because if gravity will be 0, the weight will be 0. But it doesn't mean the matter does not exist. It will exist even though weight is 0, right? For example, if a falling body is there under the action of gravity, at that time the weight is 0, right? Because the net force acting on that body during fall, free fall, I must say, at that time the weight becomes 0, right? So the weight is only 0, but the mass is not 0. Okay, I believe all of you have must understood this mass and weight, right? One more thing, the important one I need to mention here is that for mass, the SI unit is, can you guess it? For mass, the SI unit is, can you guess it, or you can tell me? Yes, it is kilogram. Kilogram is the SI unit of mass, right? Kilogram is the SI unit of mass. Then what is the unit of SI unit of weight? SI unit of weight is, can you guess it? It is nothing but Newton, right? But again, Newton is the SI unit of force, right? That means weight is a force. Yes, weight is a force, and weight has a force has a formula, mass into acceleration. That is nothing but in the case of weight, it is gravity. Gravity is nothing but acceleration of earth. So do remember this. Weight equals to force equals to mass into acceleration equals to mass into gravitational acceleration, right? So this is all the fact about mass and weight. I believe all of you must have understood. These things are not very hard. 1 and 2 times if you go through the books, you will come to know, and you can see my lecture again and again. You will be able to come to know this, right? So this is all about mass and weight. I believe you must be knowing the acceleration due to gravity, right? Here already I have told you, it is the force of attraction by which any object is being pulled by earth. That is what acceleration due to gravity. Okay. One more thing I would like to ask you, and I would like to give you as an homework to you. What is the homework? The homework is that what happened when a lift suddenly starts moving up or down. What happens when a lift suddenly starts moving up or down? Right? Just find the solution for it. Just find the solution. Right? We will talk about this situation in the next class. Okay. Thank you.